I've written many chemistry exams over the years and shot videos, but this video is different. Here I'm giving you actual exam questions with significant figures. There are 3 skill areas in significant figures. We'll cover each of those so that you'll be confident when you get to the next exam. At the end of the video, I like to do something fun that I call Wowie Zowie. So I hope you'll stick around and we'll have some fun together. Here we go. Skill number 1, counting significant figures. How many significant figures are in this number? 1.0650. And the detractors might be 3 or 4 or 5 if it's a multiple choice question. The rule says that all digits are significant with the possible exception of zeros. It depends on what kind of zero you have. Here I've got a middle zero. They're always significant. And trailing zeros depend. If there's a decimal place in the problem, decimal point, then it's significant. And there is in this case. So all of these digits are significant. There are 5 of them. 5 is the correct response. Problem number 2. How many significant figures are in this number? Here we have a number less than 1. 0.03060. Well, we know this first number, that first 0 is not significant. We could do without it even. The second 0 is called a leading 0, and they're not significant. A middle 0, always significant. The trailing 0 is significant in this case because there's a decimal point in the number. So 3060 are all significant. 4 would be the correct response. Problem number 3. How many significant figures in this number? Little bit different question because the number is written in scientific notation. We might be tempted to write it in long form, but that would be a mistake. The rule says just treat the numbers, the digits ahead of that multiplication sign, the 7, the 3, and 0. There are 3 significant figures there. 3 is the correct response. Skill number 2. We're adding and subtracting now. And the rule says count the number of decimal places, and the least number of decimal places should be used in the answer. Going to add these 3 numbers. The first one is expressed to the 1,000th, the 10th, and the 100th. So the rule would tell us that our answer must be expressed to the 10th. I've added these numbers together. 9.257 is the correct response, or the calculated response, I should say. And we might be tempted to use it. It looks a lot more accurate than this 9.3, but the rule says that our number should be expressed to the 10th. So we need to round off. Because the 5 follows the 2, we'd round up 1. 9.3 is the correct response. Do the following calculations. How many significant figures are justified in the answer? Well, that word justified might be confusing. How many are correct, or how many should be there? And again, we'll want to work the problem. Adding those 3 numbers together, I come up with 11.18118. Well, I might have been tempted on a multiple choice exam to take a little shortcut. Hey, here's a number expressed to 3 significant figures, 4 and 4. My answer's 3. But in haste, that would be the incorrect response. Because when I add these numbers together, and express the answer to the 100th, the smallest number of decimal places up here, I see that 11.18 has 4 significant figures. So with adding and subtracting, watch out. It's a tricky question. Make sure that you work the problem, express the answer to the correct number of decimal places, and then count the number of significant figures. Let me put up board number 2. Skill number 3, multiplying and dividing numbers in significant figures. How many significant figures should be used when we multiply 7.9 times 0.023? This time it's a little easier. In multiplying and dividing, we simply count significant figures. 2 significant figures times 2 significant figures. My answer must have 2 significant figures. Complete this calculation and express the answer in correct significant figures. Well, the calculator helps us a little bit, multiplying and dividing, and this is the calculator answer. And certainly looks a lot more accurate than all of these other distractors, but is it correct? The rule for multiplying and dividing, the lowest number of significant figures is the winner. 5 significant figures times 3 divided by 2. The 0 is significant in this case because there's a decimal point in the number. So my answer should have 2 significant figures. So 4 is incorrect. 5, 4, 3, 2. Here's the correct response. Rounded off to 2 significant figures. Let's give you a learning check, see how you do. Triangle has 3 sides, 3.9 centimeters, 4.2 centimeters, 5.7 centimeters. What's the perimeter? Well, we need to add. So we'll use the rule for adding and subtracting. We'll count decimal places. Well, I know right away that the answer is going to be expressed to the 10th, because that's the smallest number of decimal places up here. But I don't know how many significant figures are there. That's the catch. So work out the problem. Adding it together, I come up with 13.8, which has 3 significant figures. So I might have predicted 2 if I were answering the multiple choice question very quickly. And that's incorrect. 3 is correct, because when I actually do the work, I see that there are 3 there. Well, these are the 3 skills with significant figures. You can do this. I know you can. So be confident on the next exam. We've worked hard with this, so now let's have some fun. Let's go to Wowie Zowie. Here's something fun that you can do at home. It's easy and it demonstrates a principle of chemistry. I like to call it glitter chase. And what I've got here is a plate, some water and soap and glitter, and I'm going to have my grandson help me at this point. He's going to pour a thin layer of water on the plate. You could use a plate like this, a kitchen plate, or it could be a paper plate, doesn't really matter. And he has some glitter. He's going to sprinkle on the surface, primarily in the center and around, a little more, and maybe a little in this area. There we go. Okay, wonderful. And now he's going to dip his finger in a little soap, Dawn soap, and touch the center of the plate. Did you see that? Did you see the glitter run away? Thank you very much. That was great. Thank you. You did perfect. And the principle involved is that water has a skin on it, a surface, sort of like a balloon does. And if I were to put glitter on the surface of a balloon and then puncture the balloon, the glitter would scatter. And in this case, soap disrupts that skin on the surface of water, and the glitter moves away. Easy to do. I hope you'll have fun trying it at home.